ROMI is robotics for microfarms. It consists of a platform of robotic tools that can be customized, adapted to local situations. So understanding that these tools can be used in different ways is absolutely crucial to the project.
We try to work on a number of tools that are open hardware, like the CABLEBOT, like the ROVER, like the plant imager. These are bricks that can be reused in different contexts, for different types of farms, and that gradually we want to build upon.
Over 4 years of development and testing, we've developed a platform of tools that can work together. And that really goes from the ground-based ROVER, which has got an ability to move around a plant and move to a plant in a field. We have above that a cable system, a CABLEBOT, which can be strung in a greenhouse situation or along a polyculture farm such as this one. We are using drones to be able to have an overall vision of the landscape and changes within the environment. Finally, there's a phenotyping robot which is able to scan in detail a plant in a laboratory to help biologists or plant development biologists understand and map growth. These come together in what we're calling the farmer's dashboard, which allows somebody in situ to understand what they're seeing, understand and analyze things which they can't see, and also provide data and data sets back into a laboratory or a computational situation to try and track and understand a complexity in much more depth than has ever been able to be done before.
Agricultural equipment in general, you're looking at £100,000, €100,000. You name your kind of your range, but you're not accessible to someone who's got a very small farm. Okay, so you're looking at a lot of money. The ROVER at the moment costs approximately €7,000 to €8,000 to build. Now, as a piece of industrial equipment, agricultural equipment, that's very, very cheap. We do have a very simple web interface that you can run on your phone to connect to the robot to tell it, I want to hoe for the next 25 metres, I want to do weeding. We use a PlayStation controller actually for just driving the ROVER around the field, and this is something that anybody can learn to use very, very quickly. We're kind of targeting somebody with very minimal technical knowledge, so although you can build this, and if you're a maker, you can change the code, you can change it to do what you want. We kind of envisage a situation where actually people will just download a complete package, put it onto an Arduino, put it onto the Raspberry Pi. In fact, that will install everything and then you're ready to go.
The ROVER in that sense is maybe the sort of most practical device. We've specialized it for weeding, which is something for which there is a demand today.
Our enemies, I would say, are the weeds, as you can see. And in summer, it's terrible because here we have
One of the crucial demonstrators of the ROMI project is the weeding tool. Farmers dealing with complexity of a number of crops spend at least 20% of their time weeding. When we are able to weed mechanically, this means that we don't use pesticides, and so weeding mechanically affords us a more organic way of agriculture. And in this way, the weeding tool developed by ROMI is a demonstrator of what could be done to support some of these farmers dealing with a labour-intensive complexity on their farm. But the software, the programming and the drivers of that sort of computation don't stop at weeding, and we are able to go beyond mechanically into a whole potential of solutions.
We'd like to get these tools in the field as soon as possible so that we can work with farmers, have their feedback, but at the same time try to build a community around it, multidisciplinary, farmers, engineers, researchers, to improve these tools, augment their possibilities, and then we'll see how far we get.
You should do that one, but we come back later. We'll come and do that. Yeah. So ROMI project is interested in getting important information from the plant architecture and from the plant growth process. It's very important for a farmer to get those information just to detect very early on, if possible, any deviations from normal growth. If you have a pathogen attack, for example, and you just notice very early sign of stress in your plants, and that's generally the pathogen is not like everywhere, so it's much easier to counter-attack, especially like in organic farming when you know like a lot of chemicals to do it. And at the same time, we are developing a tool or technology to get as much information as we can from plant architecture. And this has an application towards farmers to just monitor the growth of their crops. But this can have also another application for basic scientists like me, just to understand the basic process of how a plant builds its own architecture, which is a basic question.